Lift up your eyes to the heavens. Who created all of this? For centuries, we've gazed into the night sky and dreamed. If only we could make the leap from looking at the stars to wandering among them. The history of astronomy is a story of discovery, a quest for knowledge. It's the story of mankind trying to get a glimpse into the mind of God. Hi, I'm Marcus Lloyd, and welcome back to The Universe, a journey through God's grand design. In this series, we're looking at ways that God's creation is confirmed by science. In the last episodes, we looked at early developments in astronomy. We saw our understanding of the stars change as science grew more sophisticated. But there's one thing that never changes, and that's our basic human curiosity. We want to understand the universe and our place in it. We all want to find how we fit in the big picture. That's how God made us, and He's placed gems of truth for us to find.
There's something in the human nature, and I would say it's because we bear the image of God, that seeks to understand the things around us, that wants to search out available resources or potential use of the things around us, to look what's around the corner, to see over the horizon, to want to know what's across this big body of water.
Proverbs 25:2 says, "It is the glory of God to conceal a matter, but the glory of kings is to search out a matter." We've seen how the spread of Christianity led to an explosion of scientific discovery. Educated people no longer thought of the night sky as the realm of pagan gods. Christians see the universe as a creation of the living God, which means it's subject to the same laws of physics and chemistry that apply on Earth, like gravity. Isaac Newton showed us how the same forces that cause an apple to fall to the ground also hold the moon in orbit around the Earth and the planets around the sun. In this episode, we'll see how the science of astronomy has changed in the modern age. The last century has been a time of unprecedented technological growth, and we have gained remarkable insights into the universe. But what about God? Have our more recent discoveries confirmed or contradicted the Bible? Well, let's find out. Let's see where this journey takes us next. The story of astronomy is still being written. Each new chapter brings incredible innovations in technology. Over the last several decades, we've made the leap from observation to exploration. But even before we began our voyages into space, science was revealing astonishing secrets. Take the invention of the spectroscope. The device opened a new branch of astronomy, enabling us to discover for the first time what stars are made of. When starlight is passed through a spectroscope, it is broken apart into the full spectrum of colors, each representing a specific wavelength of light. But astronomers noticed that certain wavelengths of light were reduced or missing. These appear as narrow black bands in the color spectrum. When starlight is split into colors, it acts like an atomic fingerprint. The patterns we saw match the spectrum of known elements here on Earth. And so, for the first time, we learned that stars were largely made of hydrogen and helium gases found on our own planet. The stars are creations of God, just as the Bible teaches in the book of Genesis. The spectroscope showed that all stars have roughly the same composition, but scientists saw that certain spectral lines were much fainter in some stars and more prominent in others. By the late 1800s, advances in photography allowed astronomers to record the spectra of stars on film. By comparing photographs, scientists recognized that stars fell into certain natural classes. The task of cataloging and organizing these data fell to a physicist named Annie Jump Cannon. She was born in Delaware in 1863. When she was a little girl, Annie's mother taught her about the constellations, igniting a lifelong interest in astronomy. After studying at Wellesley and Radcliffe colleges, Cannon got a job at the Harvard College Observatory, where she and a group of female astronomers were paid 50 cents an hour to document and classify stars. Originally, stars were classified by the prominence of their hydrogen lines. Ones that had bright hydrogen lines, for instance, were called A-type stars. Ones with weaker lines were labeled B, C, and so on. Cannon recognized that some of these classes were redundant and reordered the sequence so that stars are arranged into 7 classes according to their surface temperature. Today, astronomers still use Cannon's classification system.
The OBAFGKM is hottest star to coolest star. So the hot types are O, the cooler types are M. And in fact, without even looking at a spectrum, you can kind of roughly estimate the class of a star just by looking at its color. So not only does the spectrum tell you its temperature, but the overall color does as well. The blue stars tend to be the hottest and the red stars are coolest. The sun's kind of in between.
The stars in Orion are a good example of spectral types. Many of the stars we see, like on the belt stars, those are O and B type stars. The brighter ones are, there's one in the upper left in Orion called Betelgeuse, and it's a red supergiant, and it's an M type star. It's on the other extreme. But most of the stars in Orion, like Rigel in the lower right, those are all O and B type stars, very blue, very hot, very bright.
Cannon classified over 225,000 stars between 1881 and 1924. They say she could do up to 3 a minute. She was in her late 70s when she retired in 1940. The American Astronomical Society still gives the Annie Jump Cannon Award to distinguished female astronomers. But there were some troubling changes going on in the scientific community. Remember when we talked about Galileo and Newton? Those guys saw no conflict between their scientific work and their faith. They embraced the Bible. The Christian worldview inspired scientists, while the secular outlook had a limiting effect. It led them to many false conclusions and scientific dead ends. But by the time the 20th century rolled around, the influence of Christian thought and science had faded. Many people put their faith in science and forgot the biblical reasons it works in the first place. God's consistent upholding power. As early as the 1700s, some people had begun to challenge the biblical timescale of creation. They proposed that geological forces shape the earth gradually over millions of years. They began to deny the possibility of supernatural action by God.
One of the things that Darwin did was he tried to explain patterns in zoology as a result of slow, gradual changes over time. And not just time, but lots of time. Much more time than the Bible would allow. Ultimately, we're talking in terms of millions of years. And that kind of thinking eventually went over into astronomy, where they started thinking of ideas about stellar evolution, where you had stars supposedly changing over many millions or even billions of years as well.
God had promised us uniform cycles in passages like Genesis 8:22. But as time progressed, scientists, many of them, began to forget the Christian foundation that makes science possible, and they began thinking in terms of a more uniformitarian philosophy. That is the philosophy that slow, gradual processes over long periods of time can form things like Earth's geological features, as opposed to a worldwide flood, which is indicative of what the Bible teaches.
In astronomy, that philosophy sent us down some wrong paths. In the early part of the 20th century, astronomers found a remarkable pattern. The majority of stars fell on a natural curve called the main sequence.
The astronomers Hertzsprung and Russell found a pattern in the luminosity and the temperature of stars. They found that when you plotted the luminosity on one axis and the temperature on another, most stars fell along a sequence that today we call the main sequence. And even today, the plot of temperature versus luminosity is called an HR diagram in honor of Hertzsprung and Russell. But how do we explain this main sequence?
Well, very quickly by the 1920s, astronomers were developing theories about how stars aged. They thought they started off on one end and then began to cool and evolve, as it were, towards the other end. And so they began developing the idea that stars that were hot, the O and B type stars, were early and the others were late on the other end.
Many astronomers believed that this was an evolutionary sequence, that as stars aged, they cooled off, and so blue stars evolved into red stars. Well, this is completely false, and today astronomers don't believe that anymore. Today we understand that the main sequence has nothing to do with time. It's a mass sequence.
Just because you see a pattern doesn't mean that it's an evolutionary sequence. There are many ways you can interpret it, and as a creationist, I would interpret it as a pattern of God's design showing up here. And God has designed stars, particularly the sun, to last a long time because it gives stability to the sun. Doesn't mean it's old, it just means it's stable.
Still today, astronomers call stars early and late types, even though we now understand that their place on the spectrum is determined by mass, not age. This is just one more embarrassing example of secular reasoning leading to false conclusions. Secular thinking also slowed down developments in other areas of astronomy. Take the nebular hypothesis proposed by Immanuel Kant in 1755. Kant theorized that the solar system formed from nebulous material, giant clouds of hydrogen, basically. The clouds spun and flattened and finally collapsed to become stars. Most secular astronomers hold on to this idea today. By the late 1700s, Pierre-Simon Laplace and others decided the spiral structures seen in telescopes were examples of rotating nebula, becoming new solar systems. That meant that the spirals were relatively small and within our own galaxy. Could that really mean that they were solar systems in the process of forming?
Well, by about 1880, most astronomers had decided that the Milky Way was all there was in the universe. And so these little tiny disks, these little nebulae, were indeed what Kant said they were, little formations of solar systems. And this became the standard belief.
This had a profound influence on other astronomers and what they expected to see. They expected to see rotating disks of planets forming. And so when astronomers first discovered spiral galaxies, many people thought that perhaps those were solar systems in the process of formation. In fact, an astronomer named van Manen actually thought he could see rotation in some of these spiral galaxies. He took pictures separated by time and measured them, and he thought that he could actually see rotation. But of course, he was wrong.
Within a few years, astronomers were able to see individual stars in spiral nebulas, demonstrating that they were not solar systems in the process of forming, but were indeed island universes, much like our own galaxy.
This is a great example of seeing something that's not really there because of your philosophy.
Such secular thinking led to other astronomical misinterpretations, such as the evolution of life on other planets. Percival Lowell was an astronomer who lived in the 19th and early 20th century. He became fascinated with the planet Mars, but his secular thinking led him to some fanciful ideas about the red planet.
Mars is a very tantalizing planet. It comes close to us, but not very often, about every 26 months, and only for a month or two then. Lowell tried to take advantage of that, and he watched the surface very carefully. Word had gotten out from an Italian astronomer a few years earlier that he'd seen these little lines, grooves on the surface of Mars. He called them channels, but unfortunately the Italian word for channel is canali, and that got translated into English very badly as canals. And when you hear the word canal, you're thinking, well, a man-made or artificial structure for transporting water.
Lowell became convinced that these canals proved that there was intelligent life on Mars.
We don't see bodies of water, yet we see polar ice caps. And he thought that as the polar ice caps melted in the spring and summer, they built these canals to transport water to the equatorial regions where it was warmer, they could grow crops, and support a burgeoning population on the surface of Mars. Well, it all turns out that nothing was there. We've been to Mars many times with modern space probes. The canals aren't there. What he was seeing was an optical illusion. And also the ice caps were actually made out of frozen carbon dioxide, dry ice, not water ice. So almost everything that Lowell thought he knew about Mars turned out to not be true. Yet this really, for more than a half century, kind of established the popular thinking and the thoughts of some scientists what Mars must be like.
A lot of the early science fiction television programs and movies focused on life on the moon or on Mars or on Venus and what have you. And of course, today we know that these are toxic environments and there's no way that life could exist there. But again, this evolutionary belief that life is just what happens when chemistry is right has permeated the thinking of scientists who really ought to know better if they recognize that science has a root in the Christian worldview. But again, we see that way of thinking even today as scientists continue to look to space to find extraterrestrial life.
Lowell could only have imagined that human beings would one day send a spacecraft to such a barren place like Mars. Dreams of space travel have been with us for a long time. Hindu mythology tells tales of traveling through space, and from the Middle East, we hear stories about it in 1001 Nights. In the West, Jules Verne and H.G. Wells were masters of a style that influenced science fiction for decades. In 1902, the French filmmaker Georges Méliès showed us a whimsical vision of space travel in his short film, A Trip to the Moon. we were treated to a campier version of spaceflight in low-budget TV series from the 1930s and 40s. But in the late 1950s, it all got real.
Russia has blasted a man-made moon into outer space. On every continent and every land, the story of Sputnik 1 has dominated the front pages.
The launch of Sputnik by the Soviet Union and later the launch of Yuri Gagarin to be the first man to go into orbit around Earth really energized the space race as we know it. And of course, it's on the shoulders of those folks that were involved there that we stand on. When that occurred, there had already been a vision of space exploration defined, which included putting mankind into orbit to build a space station to go to the moon and onto Mars. And still, that's where we are at. The ultimate vision of, I think, the international vision of space exploration is to get people to Mars.
And it has all been accomplished using laws of motion and gravity discovered by the creation scientist Isaac Newton. In fact, virtually every modern discovery in astronomy is based on the basic principles laid out by Newton. He expected to find consistent laws in nature because he knew that God is faithful. Astronauts have risked their lives, trusting that his laws would work in space the same way as on Earth. I wonder if Newton ever dreamed that his discoveries would one day allow humans to walk on the moon. When Apollo astronauts landed on the moon, they conducted numerous experiments, including the placement of special mirrors on the lunar surface. After 45 years, these devices are still yielding important information.
They take a laser beam and shine it through a large telescope, usually at McDonald Observatory in West Texas. And that laser beam goes from the Earth to the moon, reflects off of those reflectors, comes back to the same telescope, and they send a pulse with that laser, and they measure the time difference between when they sent the pulse and when it came back. And knowing the speed of light, we can measure the distance to the moon to a fraction of an inch.
And what we find is that the moon is slowly receding from the Earth at about 1.5 inches per year. When you go back to the Apollo project half a century ago, the moon has moved several feet since then. And even more interesting, if you extrapolate this further back in time in an unlimited way, if the moon was only half as far from the Earth as it is now, then the recession would be several feet per year, because this changing distance is not linear. Well, if you do the math and extrapolate this, it turns out that the moon, in about 1.5 billion years, would be right up against the Earth. It would be right here. And you can't do that, because if the moon is anywhere in the vicinity of the Earth, our own gravity would disintegrate it and turn it into a ring. We would have a ring like Saturn has. Now, I'm not saying that the moon is 1.5 billion years old. What I'm saying is that it cannot be anywhere near that old, or we'd be in trouble. And yet we're told in the idea of evolutionary deep time that the moon is 4.5 billion years old. It cannot be. It must be much younger than that. And actually, over a time scale of, let's say, 6,000 years, then the moon has only moved a few hundred feet, which is not noticeable.
And that's perfectly consistent with the biblical timescale.
I was strolling on the moon one day in a merry month of December. May.
With each year that passed, our journey was taking us deeper into space and showing us more. The late 1950s and 60s saw the first of several unmanned probes designed for space exploration, starting with the Soviet Union's Luna 3 in 1959. Now, the plan was to photograph the far side of the moon, something that had been hidden from our view for nearly 6,000 years. The early attempts to send back pictures failed, probably because of the low signal strength. But when Luna 3 got closer to Earth, 17 murky pictures arrived. For the first time in our history, we saw things from space that were hidden to us on Earth. We were looking at the far side of the moon.
You know, we used to think that Venus and the Earth were very similar planets. They're about the same size, about the same density, about the same composition. People thought, at least in the 1950s, they thought that the Venus might be a very warm, tropical sort of environment. One problem we have is the fact that it's shrouded with clouds, very thick clouds. The Earth has clouds too, but at least there are some clear spots where you can see out and you can also see in. Can't say that about Venus. So people just thought it was maybe a tropical paradise. Very common belief up through the 1950s. By the 1960s, things began to change. We now know very different from that. One thing we know that it has a very dense atmosphere, and the greenhouse effect is just unbelievable. It's very hot. It's like 900 degrees on the surface all the time, day and night.
In 1962, the Mariner 2 spacecraft flew past Venus and was able to actually explore that by being there. That, in concert with ground observations that had been made the previous year, revealed that Venus is rotating backwards. So the sun would actually rise in the west on Venus and set in the east, the opposite of the way Earth rotates, and very slowly, by the way. Venus rotates very slowly.
That's very interesting. No other planet rotates quite so slowly, making it kind of an odd planet.
Now, both of these facts contradict what would be expected in the secular model. Because if the solar system formed from a spinning nebula, a spinning cloud of gas, really everything ought to be rotating the same way and at about the same speed, actually. So Venus just defies both of those expectations. It's very slow, and it rotates just exactly backwards from what the secular model would predict. And yet it's perfectly consistent with the creative diversity that we see in the Lord's creation.
The solar system turns out to be very different from what secular scientists thought. Earth's nearest neighbors seem to confirm the diversity of the Lord's creative mind and challenge secular thinking. But what about the outer planets? Would Jupiter, Saturn, Uranus, and Neptune follow this trend? An amazing occurrence in the 1970s allowed scientists to send space probes to all 4 of the giant planets. We'll see what they found in the next leg of our journey.